Let's do this now. Let me throw you some questions for you to ponder. And let's talk about nitrogen losses in these following systems. And it can be either related to wind or water erosional losses or not. And so let's talk about what about the losses of nitrogen in a system that's tile drained? I said in Minnesota, but it can be really anywhere. It could be anywhere in the Midwest or anywhere where there's tile drain. Now, if you don't know what tile drain is, it's what's shown in this picture on the bottom left-hand corner. And somebody has installed a drain within this field to the left that reduces the height of the water table in the field itself, allowing producers to grow crops under aerobic, not anaerobic conditions. So think about what you've learned in terms of the nitrogen cycle and what is being lost from this field with respect to nitrogen. What form is being lost? So I hope that you're thinking nitrate due to leaching losses, and you would be correct. Nitrate due to leaching losses would manifest itself and show itself most likely in this type of water because it's being moved downward through the profile off to the left in this field and coming out of this tile drain. Let's talk about a different scenario like you see in this picture here. This is obviously not in the Midwest. This is the Western US. This is an irrigated sandy soil in a location called the San Luis Valley. Now, it doesn't matter where this is located, but this soil is very sandy. It's coarse textured, and it's used to raise barley, malting barley, and it's actually this area is used to raise potatoes. So this is an irrigated sandy soil. It's obviously covered with this crop currently. So what's the loss pathway in this system? So in this system, if you think about what you've learned with respect to the nitrogen cycle, it's also due to leaching, specifically nitrate leaching. This is a coarse textured soil. It takes less water to fill the pore space, and thus water can move readily downward through the profile, carrying nitrate with it. In these types of systems that are coarse textured, what producers often do, or extension agents often ask producers to do, is to spoon feed nitrogen fertilizers to these crops. What do I mean by spoon feed? What do I mean by spoon feed is to not apply all the necessary nitrogen up front at the beginning of the growing period. You apply smaller amounts or rates of nitrogen fertilizer throughout the growing season to lessen nitrate losses in this system. Let's go to letter C. What about a dryland silt loam soil? It says in eastern Colorado, but let's just say in the Great Plains. These are systems that are rain-fed, so no irrigation. What are the loss pathways in these types of systems? Now, if you think about historically what has occurred in the Great Plains in our past, and you may not think of this immediately, but I think often of the Dust Bowl, and I think of wind erosional losses in this area. All right, and they've occurred, and they still continue to occur to this day. Not to the extent of the Dust Bowl, but they certainly occur. You can Google wind erosional losses in Colorado, Kansas, Nebraska, and I'm sure there's plenty of images out there. So maybe give that a shot. So dryland silt loam soils in the Great Plains, they're prone most likely to wind erosion. Let's go to letter D, surface applied nitrogen in no-till soils and in turf. What's the loss pathway? What's the potential loss pathway? So hopefully, based on what you know about the nitrogen cycle now, that you're thinking volatilization. I hope you're thinking volatilization. At least that should be the initial thought with respect to the loss pathway. So when we apply a nitrogen fertilizer to no-tilled soils, the soil is not tilled, if we're applying a solid fertilizer, it's the soil or the fertilizer is going to sit on the soil surface and thus increase the greater likelihood of volatilization losses based on the type of fertilizer you use. In turf, the same thing holds true because there's a likelihood that the fertilizer, it's not coming in direct contact immediately with the soil. The conversion of any ammonium-based fertilizer or any fertilizer that has the propensity to convert from some nitrogen form to ammonium has the option to volatilize. And volatilization is driven by an enzyme called the urease enzyme. The urease enzyme is everywhere. It's ubiquitous on the face of the globe. It is likely on the desk in front of me. It is likely on some pen or pencil that you're using to write with. It's certainly in soils and on soils, and it's likely on the surfaces of plant material. And so if the fertilizer that you apply to a no-till situation or to turf is not worked into the soil relatively quickly, the volatilization losses can be rather great. Oftentimes, at least with the producers that I've worked with in my past, in no-till soils, they typically use a liquid nitrogen fertilizer that is moved immediately into the soil and doesn't last or sit on the soil surface to allow for volatilization to occur. Great, this is a great approach. So we're going to end this slide set with revisiting the nitrogen cycle. We talked about the inputs to the nitrogen cycle with respect to fixation or the addition of fertilizers or amendments. We also briefly talked about the addition of organic materials from crop residues. We talked about the transformations that occur within soils, mineralization, immobilization, nitrification. Then we talked about the loss pathways, at least the major loss pathways that we discussed: volatilization, denitrification, leaching, and not on this slide is runoff and erosion. And so I can tell you that the system is leaky. Usually when you see complex systems like you see here with lots of lines, and this is a simplistic version of the nitrogen cycle, but when you see a complex system with lots of lines going all over the place, that system is leaky, and the nitrogen cycle is no exception. So the ability for us to improve nitrogen use efficiency is a real challenge. Nitrogen use efficiency is the ability of plants to take up the amount of nitrogen that we applied as a fertilizer or amendment. It's a ratio between the two. And we're going to discuss that in either 5B or 5C. And so this system is leaky. Nitrogen ends up in places we don't want it to end up. And when it goes in directions that we don't want it to end up in, that is a loss of economic return to a producer. So let's leave it here for now. I hope you learned something about the nitrogen cycle, and we're going to move on and we'll discuss other facets of nitrogen coming up.